Hello, technicians, and welcome back to the Life Safety Troubleshooter. My name is Gary, and if you're enjoying these videos, please like, share, and subscribe. In this video, I would like to talk about tools that we use in this industry. One of the most important tools is a multimeter. Now, multimeters have been around for a lot longer than a lot of you will actually realize. I was quite surprised, actually, just how long they have been around. So this is a picture of a very old multimeter. And multimeters were basically invented back in 1920 by a British post office engineer whose name was Donald McCady. And he was just frustrated by the fact that every time he had to do his job, and he was a telegrapher, he did that in phones and just general electricity. Back then, post office handled that, in Britain anyway. And he got tired of having to use a voltmeter, an ohm meter, an ammeter to do all this, so he created a multimeter. So that was the first multimeter. This is one of the first ones that you're seeing on the screen. And then, after I joined the Navy in 1973, and I went to school in 1974 to become an aviation electrician, I used this meter. Now, this is a Simpson 260. It is an analog meter. It is a multimeter. And you'll notice that it's got this kind of little mirror strip on it, and that was to eliminate what was called parallax error. So basically, it made you look straight down on this needle and not from one side or the other. So you were looking straight down at the appropriate reading. So multimeters were around for a long time, and then right around the mid to late 70s, this was invented. Now, what I mean by this, if you look over here on this is my first digital multimeter. Now, you'll notice that it says Micronta. So this was actually a Radio Shack product. And it served me well for about 30 years until it finally, after all that time, things got loose and it didn't quite work anymore. And I went to a different meter. So technology for digital meters has progressed very much. This meter will actually do Bluetooth, and you can bring it up on your phone, iPad. This one has a graphic function. So you could actually see where the current voltage or resistance changes graphically. So you can actually watch the graph, and it's a continuous readout. Now, toward the end of my career, I started using these meters. Now, these are little cheap $5 to $8 meters. Got it at a hardware store. And the reason I got these, because I needed a cheap meter, because we had this problem on a tower, aircraft traffic control tower in the St. Louis area. Nobody could figure out why we were getting these invalid replies with no set pattern. So I told my supervisor, give me a few days, cut me loose, I'll find it, and I'll take care of it. So I had 4 of these meters, so this was a Class A circuit, put one on either side on voltage, one on either side on current, and I just literally sat there and watched it. And finally it did it. And I noticed that the current jumped up. I said, okay. So divide and conquer. That's what you got to do when you're working on these things. I cut the system in half. It was Class A circuit, of course, as I indicated before. I got it down to this half. Then I halved it again. Got it down to this portion. Finally found it. It was a relay, and it was sitting there. And it would do for 140 microamps, and all of a sudden it went 2 mils, 20 mils, 100 mils. It would basically short the SLC circuit out and crash it. The problem was we did have a bunch of ISO-X's on there because it was a government job. So there was literally an ISO-X between every single device on the circuit, but the ISO-X's never triggered because this current would ramp and not go directly to a short. So it's like it wouldn't go from 0 to 60. It would go 0, 5, 10, 10, 15, 15, 20, 30. It would ramp up, gradual ramp up like going up a hill. So it would never cause the ISO-X to trigger. So it was really difficult to find and really difficult to troubleshoot to see what it was. But we finally did. So anyway, once we first figured that out, what it was doing, and this was over 10 years ago, I figured there's got to be a better way. So then I did this. Kind of homemade, but here's some 200 milliamp meters. That one's missing the cover. This is pretty old. This is probably 15 or so years old. 100 milliamp meter there. And I would stick it out on the circuit. I'd try and find a place where I can do multiple hookups. That's why there's 5 meters on there. And I would hook this thing up and I would watch it, or I would put a camera on it and put it on a DVR. So eventually I would see this thing. It took time, took effort. It was a pain, but I did it. And I found a few devices that were bad with this. Now, also had this. These were great back when they were available. They're no longer available. These are called Mushi meters. And the great thing about these Mushi meters is you stick a couple of AA batteries in them. They would go ahead and log, because they had a card in them. It would go ahead and log what was going on with your circuit. And you'd be able to determine if you put enough of these on there. And my company actually had about 30 of these things. We still have them, which is good because, as I said, they can't be gotten anymore. At least I haven't been able to find any more. And the great thing about this is you would be able to import that data and come up with this graph. Now, I had a real good technician, still have, it still works for the company, figured out a formula where we could not only do these, but it would actually show, and if you look close, you'll see the dates and the times below. So we'd be able to actually know it shorted on this day at this particular time, and this is exactly what it did. Because you can look at the bottom and you can see where the voltage dropped, and you look at the top, you can see where the current went up. So you move these things around, and of course if you put one before the problem point, you would see the current go up. If you did it after the problem point, it would go down. So you were pretty much able to isolate it. It worked really well. It let us be able to find these problems a whole lot better. Anybody that finds one of these Mushi meters out there still for sale for a reasonable price, by all means, let me know. We're always looking to buy more of these if we can, but I had to use some kind of an alternate method of doing this thing. Plus, it wasn't the only problem, okay? So the other problem we ran into was this. And what I'm going to do is I'm going to show you, and this has to do with oscilloscopes. Now, these are the oscilloscopes that are available that I have right now. And this is my original one here. This is the first oscilloscope I've got. You can see, unfortunately, the screen is broken here. You can see the dark spot. It's one of those grass liquid crystal displays, and I broke it. And the great thing about this is you could hook it up to your laptop. So I would hook it up to my laptop. And this is just an example of a good pattern that it will do. And you can see it there. It's dropping to 0. Don't pay attention to the numbers on the side. They're not accurate. But it basically, you have 3 points of reference when this does this. And the references are 0, 5, and 24 volts. And I'm going to go back. Here's a nice example right there. You've got 5, 0, 5, 5, and then all zeros going across. It's basically the digital signal identifying the different devices and modules. You'll also notice if you look at the voltage, and let me just go ahead and take this back and replay it, DC voltage would fluctuate between about 14.7, 14.6 down to 13.4. That was normal. And that's what you'd see with the DC voltmeter, and that would indicate a pretty decent and working SLC loop. Now, what I found, which was really irritating, and note that it's at 16.5, so the voltage would jump up to between 16 and 16.5 volts. So I'm going to play this one for you. And as you can see, it never drops to 0. Never could figure out why it did this, but it would definitely cause all the devices on the SLC loop to go away. And that would be a problem. Now, as you can see in this picture here, you can see where it only drops down to 5. And remember, don't pay attention to the numbers. I'm just letting you know that's 5. The one that's a little higher is about 7 to 8 volts. So it only dropped down to 7 or 8 volts. So the 0 reference, for some weird reason, instead of dropping to 0, would drop to 7 and 8. Never could figure out why. But at least now I knew I had a problem. What manifested the problem, it was just now finding the problem. Well, I had been on this job for so long, I knew where every wire nut, connection, splice box was. Fortunately, this did this to me long enough where I was able to isolate this to a single run, and it had an addressable relay on it. And lo and behold, that was what was doing it, was that addressable relay. So once I removed and replaced that addressable relay, the problem stopped. So then I moved on. Since I had broken this one, I bought this one. This one's also an oscilloscope. It's also a signal injector. So what I want to show you here real quick is I'm going to turn this on. And I'm going to go ahead and turn on this oscilloscope here. And this is an oscilloscope, multimeter. This does several different functions. So what's really great about this, it will do a meter, it will do an oscilloscope, it will do amperage, it will do current. See, you can see there's your, and it's got a little needle on there. But I want to show you the oscilloscope here real quick on this one. So I'm going to hook this up to the signal injector. And as you can see, and I'm going to bring this in a little bit closer. There's your signal. There's your square wave on this. So you can use this, or mini meters. There's a lot of them out there now, different ones, to look at your waveform. So that was great. Little bulky. Couldn't get it on a computer or anything. So then I figured there's got to be something better out there. So then I start checking. And lo and behold, I find these meters. Well, these meters are great. These are called pocket meters, and there is a link on my website where you can look at these and get a 5% discount if you want to buy any of these. This, of course, is a little less expensive than this one. This one is very small. You can see it in my hand. The leads pop out like that. And this also has an oscilloscope. Now, when you hook this up to an oscilloscope, that's what you're going to get. You could actually see this. You can change your amplitude to look at it. You can change your timing to look at it by just pinching it, like you would with a picture on your phone to make it bigger, wider, whatever. So that was great. I was able to look at that, and all with this little tiny meter. This will also do logging. So if you look at this one is called the Pocket Pro. And the Pocket Pro will do quite a few different things. And I'm going to show you, there's the interface on an iPad for the Pocket Pro. And what I'm going to do, and as you can see, the one lead pops out here. There's the lead, and I'm going to hook up my jumpers to it real quick, and I'm going to set it for voltage, and I'm going to go in here and I'm going to connect to it, and I'm going to go to the oscilloscope, and I am going to tie my signal injector to this, and this is on an iPad. I'm going to hit the trigger. And right now I have the trigger set for continuous capture, whatever you want to call it. So you can see it going through there. I can change that trigger from a free run to a forced so that I can literally go, okay, I just turn that off. Oops. Got several settings. And there you can see the waveform. But the great thing about this meter is it not only will do the oscilloscope, it will do the multimeter and logger. Now, as you can see, there's the multimeter. Now, if I hook up the multimeter, and this is on voltage DC, and I go and read my cob box, and I'm going to put the positive lead on the positive, and we're going to go back here, and I'm going to read, there's my 27.45 volts, okay? Now I'm going to change the switch on here to milliamps, because that's what you're going to use the cob box on most of the time is milliamps. And I'm going to hook it up, and you can see it's about 101 mils. If I just use my fingers, you can notice it does work on microamps. So you can take this on your iPhone, your Android, your iPad, and you can do it and watch it. I'm going to hook it up to a resistor that's drawing 11 mils and another resistor that's drawing about 5.7 mils. Now, the other great thing about this, and I'm going to switch it over. I know you didn't see it because I didn't have it on, so let me just do this again real quick. There you go. Dead short, 101, 11 mils, 5.7 mils. So that's great. I've got it set over to milliamps, and I'm going to go into logger. Now, you can see at the bottom, the red, it says each particular block is about 19.8 milliamps. So the first thing I'm going to do is I'm going to do a dead short. I'm going to start the logger. And I'm going to do a dead short. I'm going to move this down so I can see it. You can see it up there, and I'm going to hit fit so it keeps going. Now I'm going to hit the 11 mil, and I'm going to hit the 5.7 mil. You can actually watch this thing, and it is logging it right now. It is actually recording all of this to the device. So you could hook this up, go to lunch, come back, see what it did. A lot of times what I would do. Or I'd go do something else that needed to be done. So the great thing about this is when you stop the logger, like I said, it did record it. And if you go into it, you can see it recorded it 19.8 milliamps DC at 0.5 second sampling rate. So with this meter, and they both have the logger, but this one is a little bit better meter, of course. This one's got oscilloscope, logger, several other features. Now, some of the features aren't turned on yet because they're waiting for firmware updates. So when you see this range tester, power meter, waveform generator, not there yet. But you can go in and look at this. And I can set it to voltage. And as you can see, it's this switch right here on the side. You set it down to voltage. Your screen goes to voltage. And you could actually take it and read the Cobb box. 27.27 volts. Which is great. So that's meters. That's how they kind of progressed. Like I said, I really like these pocket meters. There is a link on my website that you can check them out. 5% off using my link on my website. As I look at other meters, if I find another recording meter that is more cost effective, because you know what? Nothing is cheap. And one of the things that we say in the industry is cheap isn't always inexpensive. So sometimes you got to pay a little bit of money. And I know some of you guys have bought some of these fancy meters. Depends on what you're using it for. This gives you so many multifunctions, allows you to record. To me, it was worth the money I spent on this. And I bought this when they first came out many years ago, probably 4 or 5 years ago. This I usually carry in my pocket. It's real simple, works with my iPhone. I always have it with me because it just folds right up. Put it in your pocket. So if you're enjoying these videos, go ahead and like, share, and subscribe. Hopefully I am giving you some good information on this stuff. I know the multimeters is a little bit simple for many of you, but then there's a lot of you out there that are new technicians. Hopefully this is going to help you to troubleshoot. Again, thank you for watching my video. Again, like, share, and subscribe. And we'll see you in the next video. Thank you for watching. Oh, God.